with the recording. We're going to archive this session for later access. But I just wanted to send a nice warm welcome to everyone here. As I mentioned, my name is Melissa Raspberry, and I work for the American Institutes for Research. We're the organization that oversees and manages the CS10K community. So we're really excited tonight to have, tonight here, I'm on the East Coast, but many of you I think are on the West Coast, so this afternoon for you guys. We're really excited to have our partners from SRI Education here to present for you about the future of the ECS assessments. I see a large crowd, and I'm really excited to see that. I hope others are able to log in as well, but I'm just going to go ahead and turn it over to my colleagues Carol, Daisy, and Sushi to get started. One request I do have of everyone as a participant, we do welcome you to ask questions verbally, but while you're just in listening mode, if you could mute your phone so that we can eliminate some of the background noise unless you're the one actually speaking, that would be really helpful. So without further ado, I'll turn it over to my colleagues at SRI.
Thanks, Melissa. Hello, everyone. Thanks for joining us today. It's wonderful to see participants from so many varied settings joining us for the next hour or so. So a quick round of introductions to each of today's presenters. I'm Shuchi Grover. I'm at SRI International Center for Technology in Learning, working on several projects on CS education in middle and high school, including this one on developing and testing assessments for ECS. Daisy?
I'm Daisy Redstein. I'm also at the Center for Technology and Learning at SRI International, and I'm in the assessment group, and I've been working on developing these assessments for the past 2 or 3 years here. And Carol?
Hi, I'm Carol Tate. I'm a doctoral student at Rutgers University Graduate School of Education in the Learning Sciences Department, and I'm also a graduate assistant on the CS3 project at SRI International.
And I'd also like to acknowledge our team at SRI Education who've been working on these projects, especially Eric Snow and Marie Bienkowski. And some of our SRI team members have joined us today and may answer your questions in the chat window. And of course, thanks to NSF for funding the assessment development effort and the research around it. So here's a quick peek at what we aim to cover in this hour. We'll see how far we can get, but the slides will be made available on the CS10K community website, as will the archived webinar recording, as Melissa mentioned. And I'll cover goals quickly. Carol will walk us through the process of assessment development, and then Daisy will share examples interspersed with discussions. So we'll start off with a quick word on what it is we're talking about when we say assessments for ECS. So SRI has created 5 sets of assessments, 4 of which are end-of-unit assessments for units 1 to 4. And then there's one summative or cumulative assessment covering all 4 units. And these are very closely aligned to the ECS curriculum and the CSTA standards. And they're aimed to provide evidence of students' knowledge, skills, and attributes. And we'll certainly discuss more about that a little later. And they're focused on computational thinking practices. So demonstrating proficiency in computational thinking practices goes beyond recall of facts. It requires that students demonstrate ways of being and doing when learning is being assessed on these practices. So also, I believe the ECS team has conveyed this to teachers all along in their PD sessions, but these assessments are not for evaluative purposes. And we'd like to underscore that at the outset here, that the purposes of these assessments as we see it is to support the work of ECS teachers in the classroom rather than for teacher accountability. So it really is to provide teachers with the evidence that they need to draw inferences of what students understand and know and are able to do. So this means that many of the assessments are scenario-based with short free response answers. They're clearly linked to learning objectives for each ECS unit. They often contain diagrams of figures and tables along with text to aid student understanding of the questions. So, the questions are presented through multiple representations. They're currently pen and paper-based, but computer-based versions are in development and will be made available through the CS10K website at some point down the road. And they also include scoring rubrics and additional materials such as exemplar responses and such. So the goals of these assessments is measurement of student learning, and it's to help teachers by guiding them on what and how students have learned about the various concepts in each unit. And it's not just to provide teachers with a way to look back at the unit, but also give them ideas on what teachers may want to revisit in the upcoming unit. So there's a little bit of this looking back and looking ahead that can be done using these assessments. And in our conversations with Gail and the ECS team, we've realized that assessments also help sort of meet the demands of district folks and parents and others who need to see hard data on student performance. And that we feel ultimately also helps with adoption of the curriculum. And that's true, of course, not just of CS, but on any subject really. And now for our biggest announcement. Ta-da! We are happy to report that SRI is working with the ECS team and the CS10K community folks to distribute these assessments widely among the ECS community. It's going to be a phased rollout of the pencil paper assessments first, and then somewhere on the horizon there are computer-based versions that offer more ease of administration and scoring and reporting and such. So stay tuned for more details on this right here on the CS10K community website. And if you have questions on this, you can type them out right here in the chat window, or you could email us on that packed SRI email you see there. And we'll make sure our FAQ covers all your questions. Now I'll hand off to Carol Tate, who will go over with you briefly the process of assessment development. Carol?
Thank you, Shuchi. Hello, everyone. Shuchi talked about the what, the why, and the when of the assessments for exploring computer science now being developed at SRI Education. I'm going to describe the process of how they're being developed. I will tell you who's involved in designing the assessments and what kinds of expertise we draw on as we write, field test, and validate assessment tasks. I'll also give an overview of the evidence-centered design framework we employ to guide design decisions and support the validity of score interpretation. The SRI assessment design team consults closely with the Exploring Computer Science curriculum developers, Joanna Good, Gail Chapman, and Jane Margolis. This helps us make sure that our assessment targets are structured to capture the learning objectives of the curriculum. We also gather feedback from practicing ECS teachers. And the SRI team works with outside advisors. Experts in assessment ensure that the psychometric principles of the assessments are sound. And our expert advisors in the field of computer science help us make sure that the domain of computational thinking is reflected accurately and adequately. Assessment design is an iterative process. It involves multiple cycles of development, field testing, and revision to collect sufficient evidence of validity. Teacher feedback is essential to this process. So is evidence of student thinking processes gained through student interviews. Although the assessments that will be released this fall are new, and we will continue to gather data about them, you can be assured that these test items have been well tested before they get to you. Finally, the ECS assessments are built on a framework of evidence-centered design. Evidence-centered design is an approach to building an assessment argument from what we recognize as always imperfect evidence. We can never know exactly what a student knows, but we use the ECD framework to try to get the clearest picture that we can. The ECD process is guided by a few essential questions. The first is, what claims or inferences do we want to make about students? A teacher would begin planning instruction by considering learning goals. From an assessment perspective, we begin by defining the kinds of learning we want to measure, or we define the learning we want students to demonstrate. This means asking, what are the characteristics of good work in this domain? Focal knowledge skills and attributes constitute the map of the domain to be assessed. It is these KSAs about which we want to make inferences with regard to student learning. Specification of the focal KSAs helps determine what it is that will be measured by the assessment. Next, we ask, what evidence is necessary to support such inferences? This would be the middle column on the graphic you see. In other words, what behaviors or performances would reveal that students are achieving the focal KSAs that we have specified? Then we must determine what features of observable behavior facilitate the collection of that evidence. Just as a teacher planning lessons must ask, what classroom activities will help the students learn the desired knowledge and skills? The assessment team must ask themselves, what tasks will elicit evidence that students have attained the desired knowledge and skills? The structure of the ECD approach allows us to create design patterns for tasks and scoring models. These design patterns can guide further development of assessments for ECS and for other CS curricula. As you know, the kind of understanding that ECS students should have about important computational practices goes beyond recalling facts. It goes beyond giving inputs to a program and predicting the outputs. When we assess thinking practices, we're trying to get students to demonstrate ways of being and ways of doing. As Shuchi said, we're not just looking at content knowledge. We're looking at how well students can integrate conceptual knowledge and inquiry skills to solve problems. This calls for more open-ended items that require students to communicate their strategies. This approach to assessment is in line with the new assessments of science practices, combining inquiry and conceptual knowledge being developed to support both the next generation science standards and the Common Core State Science Standards. Before I turn it over to Daisy so she can walk us through some examples of the assessment tasks and scoring rubrics created through the design process I've just described, I'll pause here to allow some time for questions.
All right. So if we don't have any questions, then we'll just get through to the meat of the matter and go over some examples. Before we go over these examples, I just wanted to make a couple points. One of them is that the examples that we are showing you tonight are from our previous year of piloting the assessments, and we are currently going through the results of the pilot and making some modifications to them. So while the essence of the examples are about the same as what you will see, some of them will have changed when you actually get the released items. And the way that we've structured this is that we'll show an example and then we'll have some time for discussion. So depending on how the discussion goes, we might not get through all of the examples. And I think it's really important for us to address your questions. So if you have them, we'd like to go through them. And the examples will be included in the slide deck, which will be made available afterwards. So we have one example from each of the units. So this first example is from Unit 1, and we call it Activities a Robot Can Do. And so the concepts and learning goals from the Unit 1 that we're focusing on here is the idea of computers and computing, and what's computer intelligence, and what are computing tasks. And it's on the learning goal about explaining the differences between tasks. And so when we translated that to our assessment goals, which are those focal knowledge, skills, and attributes, we're looking at, can students explain why an activity or task is not an example of a problem a computer can solve? And then can they actually describe or demonstrate the characteristics of a computer program? And can they describe the difference between intelligence as it relates to human and computers? So in this task, we have a short scenario that we give to the students, and often most of our tasks start off with a little scenario that they have to read, and then we have several different questions related to that one scenario. So in this first one they are given some instructions that they're going to give to a robot, and the instructions are for the robot's going to pick out their clothes in the morning. So there are things like go and take out a top pair of pants from the third drawer down, put the pants down, go back, and select, in this case we said select the most fashionable shirt, and select the shoes that your friend didn't wear yesterday. So we have them read that. And then we ask them to pick one of the steps and explain why a robot might have difficulty completing that step. And in this case, we don't actually score which step they pick. So we make them choose one, but we really are concentrating on their explanation. So what we're looking for in their explanation is something that indicates that, well, the directions aren't precise enough. They're not clear what it is that the robot's supposed to do. Or they could say something about it not being too subjective. So if they picked the line about they have to select the most fashionable shirt, and then they could follow that up and say it would have trouble because it doesn't know what fashionable means. And we did allow for, they didn't have to use exactly these words. So one way that they might describe that the directions aren't precise enough is they might say something about like, oh, the robot doesn't have all of the information that it needs. So there was a variety in what type of answers we ended up accepting. So once they pick their step and they explained it, then we asked them to rewrite the step. And so what we're really looking for when they rewrite the step is it clearer? Is it more precise? Does it, and we want to make sure it doesn't involve something subjective. So is it something that we think the robot could do? And then we follow that up with, okay, now that you've rewritten it, explain to us why you think that would be easier. And so their explanation here generally tended to reflect on what they said was what the issue was the first time when they picked that step, and then they sort of explain how they were able to solve that issue. And then the last part of this item is we follow it up with asking, is the robot smart enough to make a different set of instructions for selecting clothes? So we're trying to get, this is where we're trying to get at that idea of intelligence, and can a robot actually just come up with a new set? And so again, we didn't score whether or not they picked yes or no. It was really focused on their explanation, because some students might say yes, but only if it's programmed to do that task, or if they might mention, yes, there's AI, or something like that, that indicates that they have some understanding that there is some background that the robot needs in order to be able to do this task. Or they could say no, because robots need, again, it's that same idea that a robot needs to be programmed to do that. So that's basically our first task. So are there any questions about you know, this example? And our basic discussion question is, how are the activities in the curriculum related to this item? If there are some teachers that want to talk about that, or if you have any questions about the previous information that we have discussed, feel free to jump in. Okay.
Or maybe teachers could discuss what sort of activities they do in the classroom, you know, specific examples that, you know, you've tried out with your students to get this idea of, you know, precision of instructions and things like that across. Eric's written, don't be shy. Should we, well, someone's typing a question. Okay. A couple of being typed there. Yeah.
Yeah.
So Melissa, are participants able to talk as well on their phone lines?
Absolutely. Everyone's more than welcome to chime in, so please do if you like. But we also, it looks like a couple people, sometimes folks just prefer to put in the chat window, so we can just pause and give them an opportunity to get it typed in.
Well, I guess we could proceed and maybe come back to, you know, questions from any unit at the end of this time.
Okay. Okay. So our second example is from Unit 2, and this is the problem-solving unit. So we're focused on the idea of problem-solving and what the process is. And in this item, we're really focused on the learning goals of if they can determine if an algorithm successfully solves a problem and if they can compare the trade-offs between the algorithms. And so we broke down what we're trying to measure into if they can actually state what an algorithm would output. So that's being able to kind of follow the algorithm. And then also to do the evaluation of whether or not it solves a problem and to do some comparison between different solutions for it. So we call this clubs because the scenario is that there's a school principal and he's trying to assign students to an after-school club, or to the after-school club. And each of the students gets to pick a first choice, second choice, third choice. And we made it somewhat simple so that there's 3 clubs, there's 9 students, and the main requirement of the solution is that every club can have at most 3 students. So the first question asks is, if each student was assigned his or her first choice club, would this solve the problem? And they have to explain their answer. So the answer in this case is no, and we do expect to see a no answer, and that's mainly because if we were to go back to the previous slide, you could see that 5 students picked Club A as their first choice, and since 5 students picked it and the requirement is it can only have 3, there'd be too many students in that club. So then we give them 2 more methods for solving this problem. And you don't have to read everything. I'll go over what these are. But basically, the first method is that they go in alphabetical order, and they fill up clubs as they go along. So they start by taking the person's first choice club. If they get to a person and their first choice club is filled, then they'll pick their second choice club. If that one's filled, they'll pick their third choice club. And so that's method 1. And then in method 2, they start by putting everybody in the club, their first choice club, and then they take a look and see which clubs have too many people. And if there's a club that has too many people, they look to see if there's anybody in there whose second choice club has space. And if there is, then they'll move them over to their second choice club. So we then ask them to just basically follow the method through. And so using this method, which students would go into which club. And we do give them partial credit for their answers. So if they got them all right, they get 2 points. If they got most of them right but kind of mixed up a couple, they can still get some credit. And so for method 2, we asked them to do the same thing. But because this one was a little more complicated, we actually gave them a little bit of scaffolding in that we did the very first step for them. So we went through and said, okay, this is everybody's first choice club. Now using the method, what would the resulting thing look like? And they would have to go through and realize that for Club A, AJ, Bella, and Diego all have Club B as their second choice, so they could move any 2 of them into their second choice club. So then we follow this up by asking them if each of the methods solved the problem. And so we didn't have them explain their answer here because in our first round of piloting, we did have an explanation. We found that the explanation was, yes, they both have 3, or both methods will get 3 people in each club. And so we didn't learn a whole lot from the explanation, and so we just thought we could just cover that with just the yes or no. But then we also wanted to follow that up into the idea of what are the trade-offs, and so we asked them which method would make the most students happy with their club assignment. And here, if you follow it through, method 1 has students ending up in the third choice, whereas method 2, everybody gets their first or second choice. So that's what we were looking for there. So again, we were hoping that we could have some discussion on how this type of activity is addressed in the curriculum or in some of the activities that you guys do in the classrooms. Are there any questions, or does anybody want to talk about this idea, the activities that they use in particular? Okay, so we have a question from Sangeeta about, is there any particular reason why students are not given an option to design their own method? And that's a great question. So we actually do, in one of our items, we give them another scenario, and then we do ask them to develop their own algorithm for it. So we didn't want to do too much of that because we know that could be difficult, and we did want to focus this one more on the idea of, can they actually compare two methods, and can they see if they both solve the problem? So, but we definitely do give them that opportunity to come up with their own algorithm for something else.
So I guess one of the, just to add to what Daisy said, so one of the things that one of the big ideas that we do want to cover in this this unit is not just come up with your own computational solution, but you have to be able to evaluate what someone else has created as well, and even compare between two solutions. So that's the part that this question has done.
This is Eric So, and I was just gonna one of the things that struck me with a lot of these questions, and it's a debate we've often had, is over how challenging do we make some of these items, particularly around the algorithms. We've heard from some teachers and observed in some student responses that these appear to be some of the more difficult items around problem solving. So I'm wondering if anyone wants to weigh in about what their thoughts are, especially those that have had several years experience, on how they see their students being able to engage in this type of task, both the one that we saw and the one then that Daisy talked about, that we also, where they have to actually create their own solution. Do these seem like manageable tasks for a majority of students based on teachers' experience?
Oh, that's Sangeeta was there.
No,
Others.
Yeah, and I think the other one is somewhat similar in the difficulty of the algorithm that they have to develop. So,
What's the scenario for that one?
or it's an organization problem, where they're organizing shelves of a food bank. All right. I guess we will move on to Unit 3. So Unit 3 is the website or web design unit. And so in this task, we wanted to focus on the idea of creating web pages and based on specified objectives. So we broke that down into being able to create the specifications and then also the ability to design a web page. Because we're in paper pencil, we can't have them actually go and create one in the HTML. So we just had them think about what they would want to put on a web page and how the web page would actually look. So we just tell them that they're asked to create a website to inform people about a famous person, and so they get to pick whoever they want. And so the first part is that idea of looking at what are the specifications, so thinking of what are the requirements that you want to have on this website. And we broke that down into content elements and design elements, in part just to scaffold the type of responses that we would get. And so we were hoping to get 3 content and 3 design elements. And so we gave them up to 2 points for each of those content elements and design elements. And a lot of our discussions when we were scoring this was also what is a content element and what makes up a design element. So we had some general ideas of what that would be. And then, so then we had them actually sketch out the pages of the website. And so here they had to draw the pages, or they could describe it in words. And we asked them to include at least one of the content elements and one of the design elements that they listed on their previous page. So it wasn't just about can you create a web page, but we had them create those, what we were referring to as their specifications, and we wanted to see that they could then pull that and put that into their design. And so the scoring was basically based on looking at the 2 pages. Did the page have the content and design elements, or one from part A, and also looking at the second page as well. So this was one of our more difficult ones to score, mainly because we had a lot of discussions internally about, well, what are content and what are design elements, and where do navigation elements fit in, which is another thing that's discussed in the curriculum. And so this is actually one place we'd really like to hear more from some of the people who've been teaching this about how they talk about design and content elements and what the different elements are in the website design. Right, so we have a question about, did we consider not breaking it into 2 parts, but listing elements and why they would be important? So I think we did talk about, I have some discussions, particularly about the why they would be important. And I feel like at some point we might have tried that the first time around, and we got a lot of, well, because people need to know this, or for different things. Like I would include content because people want to know it, or because it makes it look pretty. So we didn't find a lot of information in the explanations. The other reason we broke it down is because we wanted to see if the students could identify different types of things that they would, different types of elements that they would include. So we wanted to make sure that we weren't only getting, oh, well, I need the name, I need the biography, I need this, but that they were thinking about different other things that they would want to have in the website. And just to add to that, I think at one point there was a version of this question, or a similar question that sort of talked about CSS, and it looked like there was, this is a simpler version of that, just getting them to think one step before CSS, what might you separate out as the content that you want to share versus, what is something that's about how you present that content on the website. And we felt that this was sort of a more foundational sort of understanding that we would be getting at, without confusing with the CSS, which we found was problematic for some groups of students in the pilot. And then we have another question about design elements that include color and fonts. And so we did have students who, I will say that a lot of the students did say things like color and font size. And what they would do in their drawings is they often had an arrow and said, this is green, or something like that. Or, look, this is a big font. They actually, I think I had some students who said, big font here. So they were able to indicate those type of things.
Or they'd use a word like header or title or something like that, which sort of indicated a different format or style.
Yeah. Yeah, the content was often represented by squiggly lines.
But I guess what we were looking for was things like if it was a movie star, content would be, something about their personal biography, where they were born, what they like, or something, and then a section on, what songs, things like that, so that they could identify uh, the difference between the what and the how of the web page. Yeah.
Any other questions from the group? Remember, it is okay to speak up and ask it orally. Go ahead, Don.
Am I able to, can you hear me now? Hello?
Yes, we can. Go ahead.
Okay, great. I guess my question was, so back on the previous slide, you had a chart and it had the content elements and design elements. So if a student said one of the content elements was they were going to include an image of their movie star, then does the design element have to match that? So they would have to talk about using the image tag and maybe attributes for the image tag, or can they be unrelated?
They could be unrelated. So we did see some students who tried to match them, who would say things like, I would put this in this color and this in this font, but they didn't have to match. We just wanted them
And
to
so
list
then
them separately.
okay, and I guess then my next question is, am I correct in assuming that that would be sort of a correct answer? The content element would be an image of the movie star, and then the design element would be discussing the image tag, or is that not what you mean by design elements?
Yes, so for design elements, we did include sort of formatting of the image, or like if it had a boundary or that kind of thing. When they just put the tag in, we didn't consider the tag to be the design element. So unless they had information within the tag, so if the tag only said image, then we just treated that as like, oh, that element is an image, and so that's more content. But if they had elements of design within the tag, then that would be count as design elements.
Okay.
And we did see some students who just said something like HTML or CSS, and those we didn't count as either design or content because we felt they weren't specific enough.
Because of that, did you think that maybe there's some confusion about what the two words design elements mean, and there would be need for further clarification?
It's one of the things that we're considering is that some kids did seem confused about the difference between content and design, and some kids actually reversed. So in the content elements, most of what they listed were design, and in the design element, most of what they were listed was content. So that did happen sometimes. Although a fair portion of them were able to get different elements. So we're not, one of the things we're curious about is just how standard is the discussions of content and design elements. And so we're considering if we need to scaffold it a little bit more, or if we want to include navigation elements, because we saw a lot of people putting links in there, and they put links as either content or design. And that was one that got a little tricky of, well, what is a link if it's something different? Yeah. Okay. So I think we'll move on to our last example. And so this is in Unit 4, which is the programming unit. And here you see it's a little bit similar to the task and the problem-solving unit in that we're going to give them two algorithms for solving or for doing a little program. And we're going to be looking at some of them, doing some comparison of the two algorithms. And then, but we're also going to be asking them questions about relating these to programming structures. So we have Gabriella and Lucia, and they're both programming or creating a program that has a dog running around a screen. So in Lucia's, the program just asks how many laps should a dog run, and then it checks the number that's entered. If the number is less than 2, it says please enter more. Otherwise, it just has the dog run that many laps around the screen. Whereas in Gabriella's, it checks if the number is less than 2, and if it is, then it says please enter more. And then it also checks if the number is greater than 200. If it's greater than 200, it says that's too many laps. And then if it's between 100 and 200, it only runs half the number of laps. So the first part is just asking them, so what would happen if I entered the number 120? And this is for both of the algorithms. So in Gabriella's, because it's between 100 and 200, the dog would move 60 laps, whereas in Lucia's, it would move 120 laps. And that's 1 point correct answer. And so then we follow that up by asking, okay, so now the teacher wants the dog to move 150 laps. So which algorithm should the teacher choose? And so they can pick either Gabriella's or Lucia's, and they have their explanation. So what we're looking for is that they pick Lucia's algorithm because Gabriella's would only run, if you entered 150, it would run 75. If you entered 300, it would say that's too many. So there's no way to enter a number in order for it to run 150 laps. So then we ask them, so now let's say you're programming Lucia's algorithm, and we pick Lucia's because it's a little bit of the simpler algorithm, so there's hopefully they can understand that algorithm a little bit better. And so we ask them, why would they use the if structure block? And so when we give them a little picture of the Scratch if structure block to support them in case they aren't familiar with just calling it an if structure. And then we also ask them for when would they use the repeat structure block. And so what we're really looking for is some sort of indication for the if structure that they would use this if you'd have the dog doing something different. So for checking if the number is less than 2 or not. And for the repeat structure, we would like them to say something about, oh, this is for when you're doing something over a multiple number of times. So for example, when the dog is running the laps, instead of typing in a whole bunch of different times that they would run the laps, that's when you would use the repeat structure. So we thought it would be good to have a little discussion about what part or parts of this item do you think students would struggle on and why? Or if there are questions about the item. Yeah, that's a good point because so we did do a little bit of the what would happen if you entered 120, so they could see what would happen then, and so there are other inputs that we could ask them, like what would happen if you entered something over 250, and what would happen if you entered 50. And so there's always that balance of how much do you give them and how long do you make the assessments and how much before it starts feeling repetitive. So we decided on just doing the one, but it is because we thought that would be the most beneficial because that was where there were differences between the two algorithms. But that is something to consider too.
So Jessica said that she thinks students would have a hard time articulating the why and why, the if and why repeat, why if and why repeat, because they just use it sometimes without. And I guess that's one of the things we do want them to not just, articulating is one matter, but I think they do want to be able to say that we're making a choice here or something about why we would use a certain construct, you know, just a deeper, deeper than just, okay, this is the block you pull out. Just thinking about it a little more deeply when it comes to constructing a program.
Mm-hmm. Yeah.
And actually, in our pilots, we found that this was a question they were able to answer quite comfortably.
Yeah, so there were definitely some students who would just say, oh, I'd use it to check the number, which we felt wasn't quite enough. So they had to kind of go that, like for the if statement, they had to go that next step of saying, I would use it to check the number because I want it to do something different depending on the number. So we weren't looking for long, complicated. That was sort of a little bit of a because was enough. But we did find that students were able to do that. And, we did see, like with the repeat structure, students said things like, because I wouldn't want to type that code in 100 times. I'd want to have that repeat to kind of save that. So they were able to come up with some of those explanations. Yeah, and as Eric just pointed out in the chat window that, as was mentioned earlier, we are starting to move these online, and our hope is that at some point in the future we'll be able to do some of these more interactive things.
In this unit, I'm just curious, in this unit, do children spend time away from the computer? What's the breakup? I can imagine a programming unit being, obviously a lot of time in Scratch, but do they work through, algorithms written in steps like this, or, I'm sure they enjoy working in Scratch a whole lot more, but we feel that there's value in doing some of these off the computer activities too in the programming unit, and that's something that would be helpful for answering these kind of questions. What was the last one? So we can just talk, right? No, don't say that yet.
Not yet. Okay. I was going to say, yeah, so this is our last example. So this is really the time for you guys to ask any questions that you have about anything we've presented so far.
Or any of the units, or where you think students might struggle with when you teach those concepts, or any comments really. We have about 10 minutes before we end.
Don, go ahead with your question.
Oh, well, I was just gonna, you asked the question about, when do students ever work on paper in the programming session or Unit 4? And I have occasionally my students uh, reflect on their process in uh, working on a program, especially when they're doing pair programming. And like one of the things, a question would be, talk about a time where your program didn't work, and then what did you do to try and fix it? And how was that easy, or was that difficult, or what resources did you use? So there are questions I ask like that for them to reflect on their process.
That's great. Yeah. Yeah, that's great, Jessica. I mean, I know from experience, it's hard to do that. It's hard to keep them away, but so valuable to have them think through the algorithm and design before the coding.
Go ahead again, Don.
Okay, I don't mind to be. Hope I'm not asking too many questions here, or grabbing
Not
up
at
the
all. Go
scene.
ahead.
You back in one of the earlier slides, you showed that Unit 1 would be around October 2nd, and just for clarification, so how would that be distributed? Would there be a process where we log in and download the unit test to print and give it to our students, or how is this going to how is that going to happen?
I'd be happy to jump in, say a little bit about that, Don. This is Eric. We are still working out some of the details right now with both our internal team and with the CS10K folks. But right now what it's looking like is we are hoping to distribute this via the ECS open group. Teachers would, and others would be able to go in, link to the assessments, review terms of a basic, short terms of use and licensing page that basically says, this is what the ECS assessments were designed for, which is what we shared with you today. Teacher use to measure student learning, to build evidence to use towards student grades. Other uses, so on and so forth. We have some language around that. And then teachers go to another page to download the actual assessments, scoring rubrics. They would have to, print out the assessments for their students like they would, any assessment that's not online. And then we'll have also, on a slightly more delayed schedule, be releasing some support materials around, we're doing these webinars, but then around test use and score interpretation and scoring. So like come, the new year, I think we're going to look to maybe do some of these webinars that are more focused on helping teachers with score, just using the scoring rubric and score interpretation. We can't provide direct support to everybody who's going to use it, but we do want to do our very best via the CS10K website to not only distribute the assessments, but then also the support materials to the extent that we can to help use those those assessment and rubrics, the assessments and rubrics. One thing I would add to that, Dawn, is that right now one of the things we're trying to figure out is we want to overall kind of make the process as straightforward and easy and minimally invasive as possible. And we would like to, however, know a little bit about folks that are downloading. So we may or may not, collect a name and an email address just so we know, who's using the assessments. Other than that, the process will be much like I described it, going through the ECS Open Group, terms of use and licensing page, and then downloading the assessments, which will be in PDF form, and the rubrics. We'll have that per that release schedule, and right now we're talking about how long it makes sense to keep things open for teachers, and also having a process for teachers that are either, they could be on a slightly different schedule, for example, or might otherwise need to request the assessments on a schedule that's a little bit different than our release schedule, and we'll have a process worked out for that, and that will be apparent via the same kind of pages and process that I described. But we're kind of working, not frantically, but steadily toward that goal, given that it's, September 2nd already. And I would add that we're very much excited to be able to, leverage the CS10K community, and really our goal is to be able to really leverage that community and build, an active community around the use and discussion of the assessments, because we really do want and hope that as teachers get out there and use these assessments, they have more and more ideas that they want to share and generate discussion.
Thanks so much for that, Eric. Daisy and Sushi and Carol, any final words before we close out for the evening?
No, I guess this is great. We've just advanced to our last slide.
Yeah, I think we just want to thank everybody for coming, and hopefully you guys found that useful, and we look forward to you guys using our assessments.
And as we mentioned earlier, if you have any questions related to this, please do email. And this can, even after the assessments have been released, any kind of, we'll be preparing an FAQ, but, please do stay in touch. We'd love to hear back from you, and this is, as Eric mentioned, it's all about being part of this community and helping each other, and, all toward the goal of making ECS and ECS learning a success.
Absolutely. And as Eric mentioned, we really do encourage you, if you're not already a member of the ECS Open Group on the CS10K community. I've put that link in the chat window here. So we encourage you to go ahead and subscribe and join that group so that you can be among the first to find out about this. We are very grateful for our partners again at SRI Education to provide this important information, and we look forward to having you stay connected with us through the community. If your colleagues couldn't be here tonight, I would highly encourage them. We do have another session that's coming up on the 1st, so if they couldn't be here live, encourage them to join us when we do this a second time in October, so that way they can get their questions answered then as well. So thank you all, and again, I hope you all have a great night.